measure the speed of a car at just one moment, or the slope of a hill at any given point. Derivatives are actually crucial to the inner workings of so many things around us.
When you watch a TikTok video of a skateboarder's gravity-defying jump, the derivative tells you exactly how their height changed at each split second. It answers the questions such as, was their ascent slowing down or speeding up?
So grab your notepad and get ready to explore derivatives.
Derivative is one of the most important tools in differential calculus. Derivatives give us a flexible way to measure precise rates of change, which is really cool. To put it simply, derivatives show us the instantaneous rate of change at a particular point on the graph of a function. When we take the derivative of a function, it's because we want to find the function's rate of change and the slope of the tangent line at a particular point on the function. We'll be learning two different ways to find a derivative function.
The first method, we will be introducing the formula of the definition of the derivative.
The thick mark, also known as prime, tells us that this function is a derivative.
It is typically longer but provides a deep understanding on how derivative represents the rate of change at the given point.
Here are the steps in getting the derivative of a function. Step 1. Copy the function but replace each x with x plus h. Step 2. Subtract with the given. Place it in the parentheses. All that gets divided by h. Step 3. Evaluate. We must distribute, simplify, and divide it by h. Step 4. If the function has been already divided by h, then we must substitute any remaining h with 0. The other way in finding derivative of a function is the basic rules of derivatives, which give us a quicker approach in solving for the derivative of a function. It helps us to evaluate the derivatives of some particular functions instead of using the general method of differentiation. Constant rule states that any constant has a derivative of 0. A constant is a number that does not change, and it stands alone with no variables beside it. Next is the power rule, where you multiply the given with its exponent, then subtract its exponent by 1. Next is the constant multiple rule, where the derivative of a constant k multiplied by a function f is the same as the constant multiplied by the derivative. It's almost the same as the power rule. The thing that makes it different is that it now has a constant. Next is the addition and subtraction rule, where each term is derived by applying the previous
Got a function you want us to try next? Drop it in the comments!
Now, we have provided two examples and we're going to solve the derivatives of each function.
For the first function, we are going to apply two methods in solving for the derivative of this function. Let's start with the definition of the derivatives. Let us remember all the steps we've enumerated earlier for this long method. We have 4 steps to get the derivative of this function. Let's start with the step 1. Copy the function but replace each x with x plus h. Now it will look like this. Step 2. Subtract it with the given. Make sure to place the given inside the parentheses to avoid any confusion. All that gets divided by h. We can't directly divide it by h already because we must evaluate it first. Now let us proceed to step 3. Let's expand first the x plus h cube by using FOIL method. Now that we have expanded the x plus h cube, we'll proceed to distribution. 6 is distributed to the expanded form of x plus h cubed, which is x cubed plus 3x squared h plus 3xh squared plus h cubed. Also, distribute the sign to the function inside the parentheses. Negative sign is distributed to x plus h over 2. Another negative sign is also distributed to 6x cubed minus x over 2. After distributing, that makes it 6x cubed plus 18x squared h plus 18x h squared plus 6x plus 6h cubed minus x over 2 minus h over 2 minus 6x cubed plus x over 2 all over h. Now, let us proceed with simplifying. Positive 6x cubed and negative 6x cubed will be cancelled out. Positive x over 2 and negative x over 2 would be also cancelled out. Now, we are left with 18x squared h plus 18x h squared plus 6h cubed minus h over 2 all over by h. Now, let us proceed by dividing it by h. Let's cancel this h and also in the h in 18x h squared and also on the 6h cubed, and of course we can also cancel out the h minus h over 2.
We will be starting off with the first term, 6x raised to the power of 3. We will be using the constant multiple rule. F prime of x is equals to 3 times 6x raised to the power of 3 minus 1 minus x over 2. F prime of x equals to 18x squared minus x over 2. Since we couldn't do much with x over 2, let's see if it can still be expanded to make the fraction more useful. So yeah, it can still be expanded by getting its factor. What can be multiplied to x so that we can get the x over 2 is no other than 1/2. Therefore, f prime of x equals to 18x squared minus 1/2 x, so that we can apply the constant multiple rule. F prime of x equals to 18x squared minus 1/2 x. Step number 2, derive the second term. F prime of x equals to 18x squared minus 1 times 1/2 x raised to the power of 1 minus 1. Remember the rule of exponent. X raised to the power of 0 is equals to 1. So, f prime of x equals to 18x squared minus 1/2 times 1. So the final answer is f prime of x equals to 18x squared minus 1/2. To check if our final answer is correct, let's compare the answer and we should get the same answer for both methods. Since we got the same answer for both methods, then we can confirm that our answer is correct.
Now, let's solve for the derivatives of another function, where f of x is equals to x squared plus pi x. We will be using the method of definition of the derivatives. So step 1, copy the function but replace each x with x plus h. So x squared becomes x plus h squared, and pi of x becomes pi x plus h. Step 2, subtract with the given. Place it in the parentheses and divide it by h. Step 3, evaluate, which means to distribute, simplify, and divide by h. Distribute the sign to the function inside the parentheses. X plus h squared is expanded by applying fold method. Pi is distributed to x plus h, and the negative sign is distributed to x squared plus pi x. Simplify and divide by h. So, you take out the like terms. We take out x squared and the 2 pi of x. That becomes f prime of x is equals to lim as h approaches 0. 2xh plus h squared plus pi h over h. Now you divide it by h. So that means it becomes f prime of x is equals to lim as h approaches 0, 2x plus h plus pi. So, we must substitute any remaining h with 0. So, you substitute h with 0, f prime of x is equals to lim as h approaches 0, 2x plus pi is the final answer.
Here are the basic rules of derivatives. Step number 1, select the appropriate rule to be applied in the function. Since there is an addition sign, we will be applying the addition rule, where we will be deriving each term. We will be starting off with the first term, x raised to the power of 2, where we will use the power rule. F prime of x equals to 2 times x raised to the power of 2 minus 1 minus pi x. Step number 2, derive the second term. F prime of x equals to 2x minus pi x. We can apply the constant multiple rule since pi is constant in mathematics. F prime of x equals to 2x minus 1 times pi x raised to the power of 1 minus 1. F prime of x equals to 2x minus pi x raised to the power of 0. So the final answer is f prime of x equals to 2x minus pi.
Apply both methods to test your knowledge.
And that brings us to the end of our journey through derivatives, from the slow and steady formula to the speed and power of the shortcut rules.
You've now got the tools, and with the help of this video, we hope you'll tackle both methods with confidence.
Whether you're studying for an exam or just curious about the math behind change, I hope this tutorial made derivatives more approachable.
Got a function you want us to try next? Drop it in the comments!
If this helped you, give us a like, hit that subscribe button, and share this video with someone else who's also learning calculus.
Keep practicing, keep asking questions, and keep that curiosity sharp. Because calculus gets cooler the deeper you go.